Welcome to the lecture number 69, dear students. Last time we finished question number 6. This is question number 7. This is question number 7. This is an activity based question, but I have solved it. I have solved all the activity based questions the way I am going to solve, so that you can fill in the gaps as per your choice. Now please try to understand. We have to prove that XA is parallel to Y. XA is parallel to Y. So you will find in triangle XZA, in triangle XAZ or XZA, one and the same, XA is equal to XZ is equal to radius of the same circle with center X. Now you will find XA is radius, as well as XZ is also radius and center of circle is X. So angle A is congruent to angle XZA, that is base angles of isosceles triangle XAZ. So XAZ is an isosceles triangle. It is an isosceles triangle. The reason being that XZ and XZ are congruent sides. They are congruent sides because they are radii of the same circle. If triangle XAZ is an isosceles triangle, then you will find base angles are congruent. So A is congruent with XZA. So A is congruent with XZA, base angles of an isosceles triangle XZA. Secondly, you will find angle XZA, this angle XZA and angle YZB, this angle. These two are vertically opposite angles this way. So you will find that is what I have written over here. That angle XZA is equal to angle YZB, vertically opposite angles. So as we have proved this side, in the same manner this side, YZ and YB are radii of the circle with center Y. YB is congruent to YZ, radii of same circle with center Y. Therefore, angle B is congruent with angle Z. YB is congruent with Z, because you will notice the same thing, that base angles of an isosceles triangle YBZ. So triangle YBZ becomes isosceles triangle. Why it is isosceles triangle? Because YB and YZ are congruent. They are congruent because they are radii of the same circle with center Y. Then if we compare this 1, 2 and 3, now you will find XZA is congruent with YZ, but YZB is congruent with B and XZ is congruent with A. So XZA is congruent with A and YZB is congruent with B. So B is congruent with A. Very simple to understand. So if B is congruent with A, then you will find B and A. If you consider AB as a transversal, then you will be getting XAB or angle A is congruent with angle B. They are alternate angles. And if you all know, if alternate angles are congruent, lines are parallel. So by alternate angle test, you will get X is parallel to Y. That is what we have to do. Since A and angle B are alternate angles, AB is transversal. Therefore, X is parallel to BY. Alternate angle test. Now question number 8. Question number 8 given on next page. Question number 8. Page number 86. Page 86. Two circles are there intersecting each other internally. BAZ. Okay. To prove that AX is parallel to B1, given X and Y are centers. X and Y are the centers of the circle. Touching each other internally at point Z. X is a center of a smaller circle while Y is the center of a larger circle. They are touching each other at point Z. To prove that X is parallel to B1, to prove that AX is parallel to B1. Okay, please have a look here. Join X, Y, Z. This is our construction. Join X, Y, X, Z. Points are collinear. Their collinear reason is very simple. That point of intersection of circles, point of intersection of the circles is always collinear with the centers of the circle. That is theorem only. So y x z. Okay. Now to prove that ax is equal to by, please try to understand it very carefully. In triangle BYZ, in triangle BYZ, please try to understand the triangle. In triangle BYZ, big triangle, YB is equal to YZ. YB is congruent with YZ. YB is congruent with YZ. YB is congruent with YZ. The radii of the same circle. Radii of the same circle. Therefore, angle B, I am going to write in one letter only because here there are no other angles. You may write it as B only. So angle B is congruent with angle Z. Angle B is congruent with angle Z. Angle B is congruent with Z. Reason is very simple. Triangle YBZ is an isosceles triangle. Triangle YBZ is an isosceles triangle. So base angles of an isosceles triangle B is congruent with Z. This is our result 1. Likewise, you will find, please try to understand, in triangle XAZ, in triangle XAZ, in triangle XAZ. Now you will notice XA is congruent with XZ. XA congruent with XZ. XA is congruent with XZ. Here also radii of the same circle. Radii of same circle. With center X. Radii of the same circle with center X. X is equal to XZ. Next to that, you will be getting angle A. Angle A is congruent with angle Z. Angle A is congruent with angle Z. So, angle A is congruent with angle Z. Angle A is congruent with angle Z. This is 2. This is equation number 2. Why this 2? Because XAZ is an isosceles triangle. Same triangle XAZ is an isosceles. Triangle XAZ is an isosceles triangle. Base angles of isosceles triangle. Here also we must mention base angles of an isosceles triangle are always constant. Now please try to understand. Angle B is congruent with angle Z. Angle A is congruent with angle Z. Angle Z is common. Angle Z is common. So you will find if I compare 1 and 2, comparing 1 and 2, comparing 1 and 2, Z is common, so A is congruent with B. A is congruent with B. Please try to understand. A is congruent with B. But angle A and angle B are corresponding angles if you consider BZ as transversal. Please try to understand. This is very important. B and A are corresponding angles for the lines AX and BY. BY and AX, these are corresponding angles. So since BZ is transversal, BZ is transversal. Since BZ is transversal, A and B, angle A and angle B, angle A and B are corresponding angles. Angle A and B are corresponding angles. Fine. So, if corresponding angles are congruent, then lines are parallel. So, BY is parallel to AX. So, AX is parallel to BY. AX is parallel to BY. Corresponding angle test. Corresponding angle. Okay, please try to understand once again that what happened here. Triangle BYZ, isosceles triangle BY is equal to YZ. They are radii of the same side. So B is congruent with Z, base angles of isosceles. In the same manner, X is congruent with XZ. X is congruent with XZ. Reason is also same. X and XZ are radii of the same side. Therefore, angle A is congruent with angle Z. They are also base angles of isosceles triangle. But Z is common. Therefore, you will be getting B is congruent with A. If B is congruent with A, what you will find if we consider BZ, if we consider BZ as transversal, then angle B and angle A are corresponding angles. And if corresponding angles are congruent, the lines are parallel. So this is how you will be getting AX is parallel to BY. Very important. That is what is written. YXZ in BYZ, YB is equal to YZ, YB is equal to YZ. Then you will find B is equal to Z, B is equal to Z. Next to that in triangle XAZ, XAZ, A is equal to Z. Find A is equal to Z. Comparing 1 and 2, B is congruent with A is congruent with B. Since BZ is transversal, A and B are corresponding angles. AX is parallel to BY, corresponding angles. That's it. for this. Please have a look at this. Yeah. Okay. Now let's do question number 9. I am going to solve now. Question number 9. Page number 86 only. Question number 9. Circle is given. In this circle is having center O. O is the center of the circle. The next that we find RS is a chord and A is a tangent. If I draw this A as a tangent, RS is a chord. Figure number 3.89. You will find Q is here. Point P is here. Then question asked is, if RS is 12 given, RS is equal to 12. Units are not given. RS is 12 and RS is parallel to L. Question asked is, find the radius. Find the radius of the circle. Find the radius of a circle. Okay, clear. Now you will find, to get the radius, I am going to join OS. This is radius. This is radius. Or I call this as, I label this as X. That is radius. So let radius of a circle proof. Let radius of a circle be X. Okay. So if I take this as X, please try to understand. OS is equal to P. Very important. OS is equal to OP. OS is equal to OP. OS is equal to OP. That is equal to X. A radius of spacing. Area of sides. Area of sides. Now we find if angle P is 90. Why angle P is 90? Angle P is equal to 90. OP is a radius and L is a tangent. OP is a radius, L is a tangent, so by tangent radius here. By tangent radius here. Tangent is always perpendicular to the radius at its point of contact. Now angle Q. Angle Q is equal to 90. Angle Q is equal to 90. Angle P is equal to angle Q, corresponding angles. They are corresponding angles. Why they are corresponding angles? Because you will find RS is parallel to L, that is what is given. RS is parallel to L is given. Okay. So Q is also 90. So QR is equal to QS. QR is equal to QS. That is equal to QR is equal to QS. That is equal to 6 chord perpendicular pair. Last year you all have done this theorem, that perpendicular drawn from center to the chord bisect the chord, and total RS is given as 12. If total RS is 12, so QR and SQ are 6 each. That is what is given. Okay. Now I am going to read the question again. Q is the midpoint of OP, very important. Q is midpoint of OP. Q is a midpoint of OP, very, very important. So you will find OQ is equal to PQ. OP is equal to PQ. That is equal to X upon 2. Right on this. Q is the midpoint of OP. So this is X upon 2. This is also X upon 2. Q is the midpoint. Q is midpoint of OP given. If Q is the midpoint of OP, but OP is X, therefore this is X upon 2. This is also X upon 2. Now what we have to find out? OS, that is radius. So in triangle OQS, in right angle triangle OQS, in right angle triangle OQS, by theorem of Pythagoras, by theorem of Pythagoras, you will notice OS is hypotenuse, so x square, OS square is equal to OQ square plus QS square. OQ square plus QS square. OS square is equal to OQ square plus QS square. So x square is equal to x upon 2 the whole square plus QS, which is 6 square. So I am going to simplify here. X square is equal to x square upon 4 plus 36. Square of x upon 2 is x square upon 4. Now please try to understand. X square, if I transfer this to the left hand side, x square upon 4 is equal to 36. X square upon 4, if we transfer to the left hand side, minus x square upon 4. 4x square minus x square. 4x square minus x square upon 4, that is equal to 36. Four x square minus x square upon 4, that is equal to 3x square upon 4, that is equal to 36. 4x square minus x square, 3x square upon 4 is 36. X square is equal to x square is equal to 36 into 4 upon 3. 4 upon 3. 4 upon 3. X square is equal to 48. X is equal to root 48. 12 fours. Okay. Better 16 threes. Sorry. 16 threes. 16 threes are 48. I split this 48 and 16 threes are taking square root from both sides. So x is equal to root of 16 is 4. Root 3. Very important. Radius of circle is equal to 4 root 3. No units are given, so we keep it as it is. 4 root 3. Okay. So this is how we will find, we obtain the radius of a circle. Q is the midpoint of OP. We have to find out radius. If I take radius as x, total OP is also x. So x upon 2, this is also x upon 2. OS is equal to OP is x. OP is x, same radius. P is equal to 90, Q is also 90. P is 90, tangent radius 10. P is 90, tangent radius 10. But P and Q are corresponding angles because RS is parallel to L, that is what is given. Right? RS is parallel to line A is given. RS is parallel to line A. Therefore, you will find these are 90 each. But perpendicular drawn from center to the cone bisect the cone. Cone is 12. So this is 6 each. QR is equal to QS is 6. Perpendicular from center to the cone bisect the cone. OP is equal to PQ is x upon 2. Q is a midpoint of O. Q is a midpoint of O. In right angle triangle, OQS. OS square is equal to OQ square plus QS square. OS square, OQ square plus QS square. OS is x. X square is equal to OQ. OQ is x upon 2 the whole square plus QS is 6. QS is 6. X square. X square. X square upon 4 plus 6 square 36. If I transfer to the left hand side, minus x square upon 4x square minus x square upon 4 ones are 4. That is equal to 36. 4x square minus x square is 3x square upon 4, 36. 3 upon 4, if we transfer on right hand side, 4 upon 3. 3 12s are, x square is equal to 12 4s are 48. Taking square root, 48, you can write it as 16 into 3. So 16, square root of 16 is 4. X is 4 root 3. But what is x? X is radius. So radius of a circle is 4 3 root 3 centimeter. So I am going to conclude lecture number 69 over here. Thanks a lot, dear students, for listening my lecture, as well as also I am also thankful to you for watching this video. So in this sum, we use the theorem that perpendicular drawn from center to the chord bisect chord, as well as corresponding angles are computed. Secondly, we also study in this theorem that line is always perpendicular to the radius. A tangent is always perpendicular to the radius at its outer. Blessings to all of you. Thanks once again.